In this video, I will cover a few topics involving exponential functions. We'll look at how to determine whether we have an exponential function when given a table, and we'll also look at how to write the explicit form of an exponential function. So, to start things off, explicit function rules for exponential functions can be written as y equals a times r to the x. X and y will represent any point on this exponential curve, and that's always written as an ordered pair of input comma output, x comma y. R represents the common ratio, and that is equal to 1, which represents 100% plus or minus the percent of change. So if it's an increasing exponential function like this one is, we'll add on the percent of change to 100%. However, if it's a decreasing exponential function, looking something more like that, we would subtract the percent of change from 100%. A represents the lines y-intercept, y-intercept. As an ordered pair, we always write y-intercepts as 0, as for x, and b comma a, because that's the definition of a y-intercept. What is the value of y when x equals 0? So when x equals 0, we get a because we get y equals a times some base raised to the 0, and we know that anything raised to the 0 is 1, so r to the 0, I'm going to put brackets here, r to the 0 is 1, and 1 times a is a. To identify exponential functions from a table in which the x values each increase by 1, so in this case x values are increasing by 1, we can check the values of the outputs. Let's just look at the outputs here. You know, the inputs are increasing by 1. What are the outputs doing? We're looking for a common ratio. A common ratio. And the common ratio is the value of r, and y equals a times r to the x. So in this example, the x values are increasing by 1. The inputs are increasing by 1. So we look at the outputs. And from here to here, we're looking for a common ratio. Well, if there is a common ratio, it would be 36/24. It would be times 36/24. From here to here, it'd be times 54/36. And from here to here, it'd be times 81/54. So at first glance, you might think that there is no common ratio, that this is not exponential. And that's where you want to make sure you check your ratios and simplify them to see if they have some common factors shared between the numerator and denominator. In the first fraction here, they share a common factor of 12. So if I divide 12 out of my numerator and denominator, which I'm allowed to do because 12 divided by 12 is just 1, I'd get 3 12s over 2 12s. Here, I have a common factor of 18 I can factor out of my numerator and denominator. And again, 18/18 is just 1, so I'm factoring out a 1. So I get 3 18s over 2 18s. And here, I can take out a common factor of, what would that be, 27. So I have 27 27ths inside of 81/54. So I'll factor out that 1. 27 times 3 is 81, and 27 times 2 is 54. So this is an exponential function. I do have a common ratio of 3/2. Furthermore, I want to pay close attention to where x equals 0, because that's going to give me my value of a. When x equals 0, k of 0 is 24. So there is my a value. There is my r value. So now I can write the explicit form of this exponential function. That's going to be y, which is k of x in this case. So function k, x goes into it to get output. My a value is 24. My common ratio is 3/2, and x is my exponent. Another question you might be asked for something like this is it an increasing or decreasing function, and by what percent is it increasing or decreasing? So you'd have to know how the R value is calculated. That goes back to these notes right here. It's always 1 plus or minus the percent of change. So 3/2 is equal to 1 plus 1/2. So that's telling us that it's an increasing function, which we can also see by the graph of it here. That's an increasing function. And right here is the percent of change. So 1/2 is equal to 50%. So we could say it's an increasing function and it's increasing by 50%. So continue to practice going through tables and looking for common ratios and using the common ratio and the y-intercept to write the explicit form of the function rule. Make sure you analyze any errors you make and ask any questions you have.